This video is about the demo of Lab 9. It's about to reproduce a circuit for frequency shift gain using discrete components. The objectives of this labs are understand the operation of FSK modulator and demodulator, to generate FSK signal both on hardware and software tools, to implement FSK modulator by using VCO, to implement FSK demodulator by using PLL. Student must go through this experiment and read entire experiment to understand and to become familiar with the objective and performance and how we will perform its hardware and software. Before performing the hardware for FSK, let's go through the schematic diagram to generate FSK. To generate FSK, we will use three modules. First, the master signal from which we will take the message signal, the sequence generator that will use to generate binary signal, and its clock will be the message signal which we are taking from master signal. The output of TTL of sequence generator will be input into the data port of VCO, and we have to and we'll see its output from this port on channel, and its output will be shown on oscilloscope. The earlier schematic diagram was using to produce FSK. This schematic diagram is shown how to demodulate FSK. For this purpose, we will use three TIMS modules. First is multiplier, second is bit clock wagon, third is VCO. So we will take the FSK input from our modulation circuit, and second input of multiplier will be the output of VCO, and the output of multiplier will be the input to the low filter port 1 input port, and its output port will be given the input to a VCO to the control port. The output message, we can see the output message on from bit clock wagon module. Now we will use these two schematic diagrams to implement FSK modulation and demodulation using TIMS modules on hardware. As discussed earlier, we will use a sequence generator, VCO, and we'll take a message signal from master signal. Message signal from master signal to clock of sequence generator. TTL output of sequence generator to the data of VCO. And its output can be seen on channel 1 port 1. So that is the circuit for FSK. Now we will implement circuit for demodulation of FSK. Multiplier, we will use multiplier and bit clock degenerator and VCO, as we discussed earlier in this schematic for the demodulation of FSK. So the FSK input to the multiplier, and the second input of a multiplier will be the output of second VCO, and the output of multiplier to the bit clock degenerator low filter, and we will see its output on channel 2. And that same input we will give to the VCO module. So the hardware is completed and connected for FSK modulation and demodulation. So after setting up the hardware, we can see the output on oscilloscope. Yellow one is the modulation, which is in the form of FSK, and blue one is the input message signal. We can see that and we can also see the demodulation by changing the channel 2 to B2, and our demodulation should be displayed on channel 1A2. So the output after demodulation is almost the same as the input signal. For FSK modulation by using discrete component, we will use this circuit in which we will give input digital data at 150 Hz to a transistor, and we'll use 555 IC, and its configuration is also given. As we discussed earlier, the circuit for discrete, the components has been constructed for the modulation of FSK. The output of this circuit has been shown on the oscilloscope. A signal of 150, almost 150 Hz, to the input of the circuit. And its output has been taken from this point, as we have also seen in the circuit diagram. The output which we are getting of this discrete component circuit for FSK modulator is looked like this. For the demodulation of FSK, we will use this circuit, in which we are using PLL 565 comparator op-amp of port 1710, and will take its output from its pin 9. We'll use a letter filter to filter out the output, and the input will be given to a port 2 of PLL 565, and its input will be the 1.070 Hz signal or 1.270 Hz signal. So the circuit for demodulation of FSK has also been set. We set the demodulation circuit for FSK. First we see the output of this circuit, which is used for the generation of FSK, and its input is given to the demodulated signal. The output of demodulated FSK has been shown on the oscilloscope. So the circuit's input and output has been given to demodulated circuit is 14 volts and minus 14 volts, as it is shown. Output has been taken from this point. Plus minus 5 volts has been given to this point. So the output of these two circuits, discrete circuits, for the generation of FSK and demodulation of FSK, has been shown on oscilloscope. We can see that the channel 1 is showing the FSK generation waveform, and channel 2, which is in the form of blue wave, is the demodulated message signal which we receive after implementing the circuit of demodulation of FSK. Students should note these results and fulfill their manual. That's it for this lab. Allah Hafiz.